Our experiment is operational amplifier as inverting and non-inverting amplifiers. So now let's take a look at the concept of an operational amplifier. It is a three-terminal device which consists of two high impedance inputs. One of the inputs is called the inverting input, marked with a negative sign, and the other is the non-inverting input, marked with a positive sign. And a third terminal represents the operational amplifier's output port, which can both sink and source either a voltage or a current. So as you can see in the figure, we have 8 pins, and the first pin is the offset null, and the fifth pin is the offset null as well, and the second, third and sixth pins represents the input and output, where the second and third are representing the inverting input and the non-inverting input respectively. And the fourth one, we have the negative voltage Vs, and the seventh one we have the positive voltage Vs. So this is the overall structure of an operational amplifier, and now we will be transforming them into an inverting and non-inverting amplifiers. So right now we have the formula for the operational amplifier as an inverting amplifier experiment. So this is the circuit diagram which will be further demonstrated. Here V output is equal to minus a V input, where VO is the V output voltage, V in is the input voltage, and A is the gain. And here gain equal to minus RF by Rin. So the negative sign indicates that the output voltage is out of phase with respect to input by 180 degree. Thus, in the inverting amplifier, the input signal is amplified by gain A and is also inverted at the output. Now let's take a look at the procedure which will be demonstrated. So make the connections as per the circuit diagram. Also, by adjusting the amplitude and frequency knobs of the function generator, appropriate input voltage Vn is applied to the inverting input terminal of the op-amp, and then measure the output voltage with the multimeter or on the CRO. Calculate the voltage gain of the inverting amplifier for a particular value of Re and Rn. This is a circuit diagram for op-amp as a non-inverting amplifier. And this is the formula used. So here V output equal to AVIN and the gain A equal to 1 plus RF by Rin. So these are the things we should keep in mind while performing the experiment, and let us see how the experiment is performed.
Okay, now we'll see the non-inverting amplifier. This is the diagram for the non-inverting amplifier. With respect to that, I have already connected it here. We'll see how it is going on. So first of all, we have V in to, which is connected to 3. This is the positive V in. It is connected to 3. This is the 3. Okay, this is 3. It is connected to the positive. This is grounded, and this is again grounded. Minus as well. It is both are grounded, and V in is connected to the plus 3. That is 3. Now here we have R in, which is connected to 2. R in is connected to 2. This is the R in. Here I have used a wire and kept it outside, and then connected to R in. Okay, this is the R1, and one of it is connected to the 2, and the other one is connected to the ground. One is connected to ground, and the other one is connected to the 2. Next we have another connection from 2 to 6. That is another resistor RF from 2 to 6. 2 here, this is the resistance. It is connected from here 2 to 6. This is 6. Okay, that is the output. So that connection is also done. Now now we have this positive and negative 12 volt. That is this one. The positive is connected to the 7 of the IC. This is the 7 of the IC. It is connected to 7, and negative is connected to, this is green one. It is connected to the 4 of the IC. Now we have the multimeter here. Multimeter COM is connected to the ground, and this one is connected to the output. Okay, so here we are receiving the output. Now this is all about the setup. Now we will see how when we are changing, how it is changing over here. Okay, now for taking the values, let's say we are using the force here and making it, let's say we are starting from 2. Okay, now if I am keeping 2 here, I should receive 2 here. Okay, if it is positive, again here it should also be positive, because we know V naught or V output is equal to 1 plus Rf by Rin into Vin. Rf by Rin, we are taking the resistance as similar. It is of the similar resistance. The resistors. Then here if we are taking it as 2, here we should get 2. But as the IC is slightly damaged here, we are getting it slightly decreased in a slightly decreased value. Okay. So this is about the non-inverting amplifier. Similarly, if we change it to 3, we should get 3, and like that it goes on. 3, or if we are taking it as like this, 1 plus 1 into, if the V in is, let's say here it is 4 into 2, we should get one value. That is the value that we should receive here. But as the IC is damaged here, we are not able to get.
Okay, so let's start the op amp as inverting part. So see, we can see the circuit diagram here. So we have already connected according to the circuit diagram. So for what we have done here, we kept the IC chip here. From 2, we have taken one connection to one point. From there we have connected one resistance. Then another resistance is connected from 2 to out 6, and minus VCC is connected to, as you can see, this minus VCC is connected to 4 and plus VCC is connected to 7. Then this supply we have given one to this resistance, and we have shorted this supply, and one is given to the earth, and this negative part is also given to the earth. So then we have connected this with a multimeter, and this COM is, one is given to the output part and another is given to the earth. So let's see this procedure. So if I am doing, as it is inverting, if I am giving an input of minus, like if I am giving an input of 1 volt, I should get it, actually I should get minus 1 volt. So if I am, see, as you can see here, I am doing fine adjustment. So currently I am keeping it in 0. So as you can see, now I kept that in 1.3. Now I am kept that in 1.3 or 1.4 range. As you can see, we are getting an output. Actually IC has some problem, that's why it is not, and multimeter also has some problem, that's why it is not giving an exact or clear value, but it is almost giving. When I gave 1.3, I am getting an output of minus 1.26. So if I gave a positive value and I got an inverted value, that is just opposite that 1.3, I got negative minus 1.26. Similarly, if I am because we are getting exactly same, because I have given here same resistance. So according to the equation, if resistance is same, so we will get exactly opposite of the input.